And I have a problem with my computer camera. I cannot open that. I don't know what is going on, but the computer cannot detect the camera. And please speak with me. Don't text me, huh? Please. I don't like texting. But Sarwa is not enough 2 sessions. Is not enough at all because we need to move fast. So it's but it's not 2 sessions are not enough at all because I have to work.
So, no.
Okay, so today we will speak about the pulmonary mechanics and loops. Okay, loops are the relation of pressure, volume, and flow to each other. We have two very common that we will discuss today, and we'll pass the other ones. The pressure volume loop, the very important, and the flow volume loop. And it gives us one breath mechanics. It does not show us the trend. Now, the scaling affect and distort the loop if the computer has no automatic adjustment. It can be clockwise and it can be anti-clockwise. So be sure that what are you looking for. So the first one is the pressure and volume. So when I give a pressure for a long time, I will give volume. And when I give a pressure, I inflate. And once I inflate, that's mean the object are distensible, and that we are talking about compliance. So, and the compliance can have a poor, stiff lung, and flexible, elastic lung, high compliance. Compliance is the change. And remember, whenever you see a triangle in the computer, mean change. So compliance is change of volume over the change of pressure. While resistance is the change of pressure and the flow. Resistance, we have inspiratory resistance affecting the upper airway, and we have inspiratory resistance. And you will see the resistance, whether it's inspiratory or expiratory, in the mid inflation point. So we'll have something called inflation points. So we have lower inflation point, we have higher inflation point, we have higher deflation point, and we have lower deflation point. In between, there is mid deflation. And there is something called hysteresis that you will learn today. I know there is terms. The hysteresis is the difference, the distance between the inspiratory and expiratory limb. The normal loop, the pressure volume loop, is an oval. However, the inflection point or deflection point can affect. Are we recording? I forget. Oh, no, we're not recording. Oops. So let's go back because I need to record, very important. So I'm going to repeat. Oh, now we're recording. Sorry. Okay, so this how a pressure volume loop looks like. So we have here a pressure and we have here volume, and this white limb is the change of pressure over the change of the volume. So you can see that the pressure volume loop never starts at zero because it starts at PEEP. There is always a pressure here. Okay, and then the pressure goes up, goes up, goes up, goes up, and the volume goes up. the pressure goes up until we reach a point at the end of inspiration, and then start to go back to zero, and so on. Now, if you see, here is the difference of a pressure over volume, okay? And this limb or this slope represent the compliance, okay? So when it goes down, that's mean decreased compliance. When it goes up, that's mean increased compliance. How? Because once it goes down, that means we are giving more pressure but getting less volume. Once it moves up, that means we're giving less pressure but getting more volume. So improve compliance. So when this goes down, decrease compliance. When it goes up, improve compliance. So this, the point from here till here, the dotted line are the compliance. And the difference between the inflation and deflation, the distance, are called hysteresis. And the hysteresis represent the resistance. Okay, so this is the maximum volume and this is the maximum pressure. This is inspiration, this is expiration. It's a volume pressure loop. This is the PIP and this is the P. Now, if you do not understand anything, you have to ask questions. So please, if you have a question on this slide, ask. Even if you think it's silly, even if you think it's stupid, ask it, please. Okay, so if you have a question on this slide, please speak up and ask questions.
Hello, dear doctor. How we apply this practically, clinically to the patient?
Don't jump. We will apply it together, but don't jump. I'm asking a question. Do you understand this slide? That is my question.
Doctor,
Not
just because,
we will apply it clinically together. Sorry?
Just because it's new, can you repeat this for confirmation?
This is called loop.
Please.
And loop is the relation between two parameters. So this is a pressure volume loop. It relates and it gives us the changes of volume and the pressure. So once the pressure increases, the volume will increase. So it not start as zero because it always start at after PEEP. So this is PEEP, centimeter water. This is PIP, centimeter water. And this is the tidal volume, mil. Okay, this is the tidal volume. So the pressure starts by starting the flow. So the pressure is increasing, but the volume is increasing too. And then it reaches to the end. Once it reaches to the end, the volume will reach to the end. Okay, and then it goes back to zero. And then wing up, wing down, wing up, and so on. It continue moving. And it shows the breath. So this is slope, this dotted slope is the relation between the pressure and volume. And this is what we call it compliance. So if this line goes down, okay, that's if this line is in here at this line, that's mean we're giving same pressure but getting less volume, which means the compliance are poor. If the line goes here in this point, mean we're giving less pressure but getting more volume. And that's mean we have a better compliance. So the direction of this dotted line or slope represent the compliance. Now here we have a deflation and inflation and deflation, inspiration, expiration. The distance between them represent the resistance. The distance between them represent distance. It never starts, this graph, it never starts from zero because there is PEEP. Okay? And this is pressure in centimeter water, and this is volume in mil. Is that clear?
Yes.
Questions before I move?
Doctor, do you have any example of poor compliance and better compliance?
Yeah, we will see. You are jumping. We
Okay.
will see. Once you understand,
Okay.
we will see all the evidence, all the problem.
Okay.
We'll see it together. Okay. So here we see more understanding. Okay, same volume and pressure. Okay, so once the line move like this, we have better compliance. Once the line move like this, okay, we will have poor compliance. Very important. Now you see it always starts from peak, not from zero. And you can see the line are moving very slow, very slow. There is more pressure, less volume, more pressure, less volume, until we reach a point, this is the dot line, where a little bit of pressure get much volume. Okay, and then there is a point where if you can see here, there is a point where you get more volume, again, you get less volume. You can see here, again, I will repeat, you get little bit, there is more pressure, less volume, more pressure, less volume, more pressure, less volume. At some point, you get small amount of pressure, much of volume. Then you reach a point, again, you get more pressure, but less volume change. And then you get decrease in the pressure, no change in volume. Decrease in pressure, no change in volume. And at some point, a little bit of decrease in pressure, you get your win, decrease in volume. And then you reach another point where decrease in pressure, you get less volume change. Is that clear?
Yes, yes, good.
Okay, so now we'll make it more complicated. At this area where after the pressure reach maximum and there is no change in volume, we call it overinflation, overdistension. While at this point where there is a little bit of changes but no volume, we call it underinflation. While this area, we call it the safe zone, the good ventilation. And this is the point that we were talking about. Is that clear? Or you guys want me to repeat? Questions? Okay. Now we will speak about not the pressure volume, it's about the flow volume. And if you guys remember, whenever we have a flow, we have over and under the line, not like the pressure volume, only positive, but when a flow is involved, because we have in and out, so we have a positive and negative flow. So this is what we call it a pressure volume loop. It relates the volume to the flow. And you can see flow starts here, we reach to the maximum flow, or what we call it the peak inspiratory flow. And that's what we call it forced inspiration. Then the flow decrease. So up, increasing flow. Then at point there is no change in flow, the same constant flow. And then the flow decrease until we reach a point, no flow. And then the flow will become out, until we reach a maximum point, peak expiratory flow, and then goes back to zero. And once you reach maximum flow in, you get the maximum tidal volume, because this is time. And if you remember, the volume is the time of the flow. So this is our volume. And then the volume is the same, then the volume decrease until we reach maximum outflow, and then it decrease the outflow until we reach back to zero volume. So this is acceleration in, this is deceleration in, this is acceleration out, and this is deceleration out. Now, is the flow volume loop clear, or you want me to explain more? Okay. Now, if you guys remember, if the machine does not go back to zero, that's mean, what does that mean? Because remember, it always has to go back to zero. Okay, start from zero and go back to zero. If you don't go back to zero, what does that mean?
There is leak, Minister.
A problem. Always remember, we have a, whenever you don't go back to zero, you have a problem. When this not equal this, we have a problem. So right away, whenever you have a problem then. And now look at this flow. We are getting up, 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 but we are not getting, you know, there is more flow, okay? There is very less flow, but we are getting good volume. You see? You get less flow in and you get better volume. And then we get less flow in and the volume remain. So from where the volume is coming? Coming from the previous cycle. And that's what we call it air trapping. Okay? Please don't text me. Habibi, Abuya, Allah yahfadkum inshallah. Please. I don't know why you don't understand this. Please, kindly. Allah yakhallikum yustar alaykum. Do not text me. You have to speak up because I cannot look to the text. Okay, it says this. We have very high flow, but no volume. We got very good flow, but no volume. You see flow, oh, up. But the volume is very small, restrictive lung problem. Okay, very high flow, but no, very important. Flow volume loop. Now, I will pass this because it's too much theory and little application. So I'm going to pass this time constant. Now, we will look at the decreased compliance. So you can see more pressure, more pressure, more pressure, but we're not achieving volume. The slope is down. Okay, and that's what we have for compliance because the slope is down. Okay, and here you can see the inspiratory hysteresis is less than the expiratory hysteresis. So this, from this line till here, and from this line till here, on inspiratory side is less than the expiratory. The expiratory is bigger. So we have upper airway problem. So we have poor compliance and upper airway problem with this graph. Now, is that clear? Any question? Okay, now we will get it better more. So you can see volume versus pressure target. So you can see volume and pressure. Here, this is the volume. This is the pressure, sorry. And this is the volume. So you can see here, okay? You can see here. We have a pressure target. Okay? So we are telling the ventilator, stop here. So we are getting two volume. Okay? You see? We get this volume and this volume. So pressure target, the volume are changing. Look at here. We have the same volume, but we have different pressure. Yeah, again, you can see the pressure. We have one pressure, but we have two volumes. So pressure target, because the pressure is fixed. Look at here. We have two pressure, but the same volume. So volume target. Clear? Questions?
Yes.
Oh, look at here. So this is measuring the volume and the pressure. Give us the trend. So that's the importance of looking at trend. We started at 2 p.m. and ending at 4 p.m. So you can see the pressure, the need for pressure are decreasing. You can see the volume are increasing. Compliance is better. These are by number. So this, they may give, the baby might be improving because of edema, or you gave Lasix in heart failure, or this is received surfactant, or whatever the reason. So you can see the pressure is getting better while the volume is improving. So the patient is improving. This is when we do trend of loops. So we get more loops and or graph over time. Now, is that clear? Okay.
Sorry, Doctor, can you repeat
Now,
this? The previous one? Yes, this one.
This one, you see 2 p.m., right?
Yes.
4 p.m.
Okay.
This is the pressure are measuring. This is 35 and this is 18. So the pressure we're measuring, you can see the pressure is going down. The pressure is going down. The pressure is going down. The need for pressure is less. The volume is going up. The volume is going up. Less pressure, more volume, better compliance.
Okay.
Okay, now we will talk about the points that you guys remember. Okay, so this is called lower inflection point, where the volume change with less pressure change. This is called upper inflection point, where the pressure change give you less volume change. So more pressure change, no volume, pressure change, better volume, pressure change, no volume, upper and lower inflection point. Although this also called opening point, where you give more pressure, alveoli are not open, more pressure, alveoli are not open, more pressure, alveoli not open, and now all of a sudden the alveoli open, you get good volume. And you can try this on the balloon, and we will try it inshallah on practical. This is called opening point. This is very important point. Very important point. Because this has to be less than double of the PEEP. And that's why how we select good PEEP. So this has not to be more than, so if the PEEP 6, this has not to be more than 12, because this is centimeter water. There is PEEP, there is PIP. So from here till here should not be double. So if the PEEP is 8, this can be 16. If the PEEP is 5, this should be not more than 10. So the starting of PIP until the opening pressure should be not more than double the PEEP. Okay, if you get less, you get underinflation. Okay, if you get more, you get overinflation, and then you reach a point where again more pressure give you no volume. So this is the this give you overinflation. And now we will learn something called compliance. C is a compliance. Okay, now you will learn what we call it C20. Okay, this is called compliance dynamic. This line dotted called compliance dynamic. Okay, and this dotted line represent the opening line. Now, if we make a line from this till opening, and then we make another line from the end till the C dynamic, and it's parallel to this line, we get another line, and this line called C20. The C20 is the remaining 20% of the lung. The remaining 20% of the lung. Okay, and if it's 1, the C20, which is the remaining last 20 of the lung, over the whole lung is equal 1, then this is over distension. That means the last 20% of the inflation is equal to the whole lung, and that's overinflation. This always has to be less than 1. So if it's less than 1, no overinflation. If it's more than 1, it's overinflation. The best to have it 0.5. Okay? Do you understand this? So this is the compliance dynamic. This is the line from starting of PIP until the opening pressure. This is the line from the end of inflation, and it's parallel to this line until it touches the C dynamic. The longer this one, the bigger the compliance, the C20, or the last 20% of the inflation. And if we divide the C20, this line, over this line, this is the compliance, and this is the C20. So C20, the distance of this line, over this line, if it's equal 1, mean this line equal the whole line, mean the last inflation of 20% of the line equal to whole line. And this is mean overinflation. So if the machine show you that C20 divided by C equal 1, mean you have overinflation. The best you have it less than 1. And the beautiful things less than 0.5. Okay, again, you can see good distance between the compliance dynamic and the inflation, and also the distance between C dynamic and the deflation. So the hysteresis are good. Questions? Any question? So now you learn the deflation point, upper and lower inflection point, the inflection line, the deflection line, upper and lower inflection point. You learn the C dynamic or the C slope. You learn the opening line, and you learn the C20 line. And now you learn the overinflation and underinflation. Any question? Okay, this is hyperinflation. It's easy to know because the C dynamic, the C20 over C is 0.8. And remember, we said it should be less than 0.5. And you can see also that inflow is more than outflow, which means that we have overinflation. This is the independent values, this is the dependent values, and this is the volume pressure loop. Clear? Okay, underinflation, we're going down. You see, there's the difference. Overinflation, underinflation. We're not opening, we're giving pressure, but not improving. You can see now improve. But there is a problem here. You say the inflation, okay, is less good than the deflation. The inflation line is close to the C dynamic. So we have very small distance between the C dynamic and the inflection line. So we have inspiratory problem, but we have good inflation and we have good deflection. Okay, because our inflation is improving. Questions? Okay. Now, if you guys remember pressure overshooting, that we took it in the graphics when we have a notch. So the pressure goes up and it becomes over the P plateau. This is the P plateau, you can see. And you see it here in the pressure volume loop, very clear. Okay, you can see notch. But here, because it's on both sides, it's a flow. So it's a flow with the volume. And remember, it can be clockwise, it can be anti-clockwise, depending. You can see the notch. Pressure overshooting. How we fix that? We increase the flow or improve the inspiratory time. I will show you how we fix correction of the pressure overshoot. Now you connect it, adjusting the rising time. Okay, or it can be corrected automatically based on the machine. But if there is, we change the rising time. And if you guys remember, the rising time, also sometimes called rump, depending on the ventilator, it represents 30% of inspiratory time. So if the inspiratory time is 60, the rising time should be 20. If the inspiratory time is 0.6, the rising time should be 0.2. So the rising time, remember, it's always to be 30%. However, this is the starting. You look at the graph, you look at the loops, and then you adjust it. Air hunger. Get more pressure, no volume. You get more, look at the pressure, look at the volume. Now we are reversing. Remember the orientation, okay? So we are getting very high pressure, but getting less volume. Okay? Air hunger. How we improve it? Increase flow, we increase the tidal volume, and we tell the patient to breathe a bigger breath by increasing the inspiratory time. Air hunger, more pressure, less volume. Okay, low tidal volume, the measure. Increase work of breathing, more pressure, less volume. Clear?
Yeah.
Okay, increase inspiratory resistance. Okay, so we can see here, moving in, moving in, moving in, more pressure, but we're getting nothing because this is flow and this is pressure. Flow, 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 but we are not able to increase the flow. We're just plateauing the flow, but during inhalation. So we have inspiratory problem. How we improve it? We give it more time, or we increase the PEEP, or we give higher flow. Clear? Okay, increase expiratory resistance. Okay, so you can see here the distance between the C dynamic and the inflection line is less than the expiratory line. And we have bumping, we have increasing, we have convexing the expiratory line. So we have big expiratory problem. Okay, so what we do is we decrease the inspiratory time or increase the expiratory time or improving the PEEP. So that's why, remember, the PEEP are very important. The PIB should less and the PEEP should be high as much as we can without making a problem. And the PEEP, don't be scared of PEEP. This is wrong. What will happen? You get pneumothorax. Okay, we can put chest tube. That is not a problem. Okay, but if you ventilate wrong, you will cause chronic lung disease. Okay, so this is usually happen when you have a ball valve endotracheal tube obstruction. Okay, you have an, or you have you have a patient with asthma or bronchiolitis. Now look, when we give surfactant, you see that there is inspiration a little bit bigger than the expiration. And during expiration, you can see going up, no change. And then we're not going up in a nice line. We have a scooping. We have low line here, the expiratory in or expiratory rise, and then expiratory slow is not curving. It should come here and then go back. It should be nice looking like this. So we have in the volume flow loop, we have scooping of the expiratory deceleration. And here you can see the inspiratory line are closed to C dynamic. However, the expiratory line is away from the C dynamic, which means the expiratory hysteresis is bigger than inspiratory hysteresis. So we have a problem, okay? And look at the tidal volume, okay? We're giving more pressure, getting only 20%. So you can see the C dynamic, okay, are very small. Now let's look here. Now you can see the N become better, and you can see the C become, instead of 20, become about 30. And you can see the improvement a little bit in the line. We are getting more tidal volume. So look at the tidal volume. Look at the tidal volume. Look at the tidal volume here. It's like picking up in here. Look at the tidal volume here. It's become 30. Look at the tidal volume here. So flow and the flow versus volume and the pressure versus volume are improving. Now, inspiratory hold, you can see we're losing the segment. So we are plateauing of the flow. oh, sorry, the pressure against volume. So we have some time where the flow is not showing or it's staying at the same. Or we have distortion, we have disconnection, we have empty area of the pressure and volume loop. So you can see disconnected. Once you see disconnected, that means the patient is holding and the hold is too long. So we're distorting the upper portion of the pressure volume loop. And that's what we call it ballooning. And ballooning means you have very high flow or you have long inspiratory time. Okay, and usually we see it in here also. If you guys remember, we have positive and negative deflection of the flow graphics. And remember, we said this should be continuous with this. If the pause are prolonged, that means there is pause. If the pause should be coming here, it should not be direct because that means we're not giving time for the patient to to wait a little bit before expiration starts. But we can hold it for a long time, and you can see the hold here. So this is not good if you guys remember from the practical session. This has to be directly with this, with a little bit of pause, not this prolonged pause. Clear? Okay, flow volume loop again. So we can see that the flow is accelerating until we reach a peak inspiratory flow, and then decelerate until we reach no flow, and then accelerate out until we reach peak expiratory flow rate, and then we go down. But you can see this is not going back to zero. So if it stay here, remember we said trapping, but it reached before the time, that means we have a leak. Okay, so we have a leak here. Okay, and we have peaking also. We're losing the void shape. Okay, but please remember, some machines are the inspiration starts from here and then come here. So remember, it can be anti-clockwise. So make sure that when you look, you're looking correct way. Okay, so we can see that we are rapidly reaching the peak and slowly going down. Okay, so you can see also here there is leak because this has to. So if it stay here, air trapping. If it stay here, leak. Now look at this. Look at this. More flow in, but no volume. Inspiratory problem. This is big. Good expiration. Remember, in has to equal out. Small n, inspiratory problem. Big out.
Air trapping. It was air trapping.
It's the flow. You're giving good flow, but you're not getting volume. And there is air trapping here. You're right, because it's not going back to zero.
Yes.
And it's starting above zero. So it's not going back to zero and starting from above zero. So very important. Okay? But the point here that inflow is smaller than out. Okay,
yes.
so you're giving more pressure, but you're getting resistance. Now you look at here, this is going right away high, but going slowly back. And this bigger than this. We have expiratory problem. Now you can look at here, this patient having high flow, but not achieving the volume. Once we give bronchodilator, we are getting a little bit improvement of the flow and improvement of the volume. The volume become 12 or 13. Okay? This is called excessive dynamic air collapse. So the airway are collapsing during expiration because of a floppiness, so laryngomalacia, tracheomalacia, and so on. And you see this notch. So normal is this one, and the abnormal is this one. This is normal, this is abnormal. Okay, dynamic, or we call it EDAC, excessive dynamic airway collapse. Okay, look at here, a beautiful picture. Because we see screen, we see numbers, and we see graphs. Very important. We see the set, we see the measured, we see the trend over time. Okay, this is the time. So if you can look here, the tidal volume was good. All of a sudden, the tidal volume decreasing. The pressure was good. All of a sudden, we need more pressure. We're losing the tidal volume. Maybe because of tachypnea, maybe because, but this patient was tachypneic. But also maybe other reasons. Okay, surfactant administration, very nice looking. Okay. So you can see the tidal volume was here and then all of a sudden increasing. You see the pressure was high and then decreasing. You see less pressure need. Endotracheal tube leak. Okay. You see, never goes back to zero. Big leak. You see, okay, it's not going back to zero because you have to reach zero in here. Does not should go back. So we can have inspiratory flow, tidal volume, and then exhalation, and then no more exhalation. Where is the air going? It's leaking because we're not completing the exhalation. And you can see the leak here also because it's not going back to zero. Remember, always has to go back to zero. Secretion, you see, so like picture, very common. Once you see it, we need section, and we will have a specific training on the nurses how to section and when to section. Okay, and how frequent we section. Clear? So you can see so like turbulence, irregular line of presence of secretion. And I am done with this session. So let's stop recording.